Raj Patel the geologist.
Raj Patel the geologist. Raj Patel the geologist.
Hello ladies. So today for my sandcastle experiment, I have Lara as my assistant. That also rhymes with Raj Patel. And then I also have Madeline, the Sadaline. Okay, so today we're going to be doing the sandcastle experiment, which represents
Our sandcastle experiment represents the part of the rock cycle where the sediments come together and are compressed underwater and they eventually form sedimentary rocks. We have our sand here, which represents one part of a sediment, which is our base, and the other ingredients here, which represent all the different array of sediments that come together and form sedimentary rocks eventually.
So magma is the molten rock within the Earth's surface. When it cools down, it turns into igneous rock, which is also known as fire rock. Now, if igneous rock were to melt again, it would turn into magma. Igneous rock, after intense weathering, erosion, and deposition, turns into sediments of all sizes. After compression and cementation down on the surface of the sea, it turns into sedimentary rock. Sedimentary rock will turn into sediments again after weathering, erosion, and deposition. Now, both igneous rock and sedimentary rock turn into metamorphic rock after intense heat and pressure. Once the metamorphic rock melts again, it will turn into magma, and if it experiences weathering, erosion, and deposition, it turns into sediments again. Now remember, people, okay? The rock cycle does not have a beginning and end. And why is that? Because it is a cycle.
What's that?
Whoa! Oh my God!
DJ Giella Joe. We got some glue, solid oil. We got cement and water and yogurt and soda. These ingredients are our sediments for our geologic experiments. DJ Giella Joe out. And sand.
That was a rock solid performance, DJ Geologist. Whoa.
The rapping game is hard, okay? Bear with me.
Sorry. Back to Raj, guys.
So, back to this sandcastle experiment. Remember, you boys and girls can do this at home. All you need is some sand and some sediments. Guys, remember, we're sponsored by Elmer's. Follow us on Instagram, Snapchat, Twitter, merch link in bio. So, I'm going to have Lara explain to you what to do.
Okay, so first, we're gonna take parts of the ingredients and mix them with the sand with the little cups as our frames to make our sandcastles.
Okay, so now we're actually going to start mixing all of our ingredients together to form different miniature sandcastles to show the different sediments that come together underwater.
Remember to fill up half the glass with sand.
So, since Raj Patel's on a date right now, we'll be taking over the experiment.
Yes, I'm his assistant, Madeline, and I'm going to be helping you eager viewers at home to understand one of the experiments. I'm going to be showing you how to properly execute the experiment with sand combined with water. So the combination of sand and the ingredients here do not necessarily have to be equal. So for this one, I'm going to add a little bit more sand. About there is good. And I'm going to pour water until it forms some sort of damp sand mixture. Now just mix it to get the water all the way to the bottom. There. I'm going to add a little bit more sand. We have a miniature sandcastle. Now do the same with all of the other sandcastles and the mixture of different ingredients so that they form a little bit of a mixture like this.
So now we're gonna repeat this step with all of our other ingredients.
I took some soil and I mixed it with a little bit of water to create a new mixture. So now mix your soil and water mixture with your sand. So our next one is the salt. Yeah, the salt and the sand mixture. So I put a little bit of water in with the salt. For the next one, actually, we used cement, like the dry cement like this, and we just mix it with a little bit of water. So for the last one, this one is just sand. So just fill it up all the way to the top with sand, nothing else.
So, when you're done filling them up, you're going to take each cup and flip it over on a surface that you don't mind getting wet.
Some of them might be a little bit more difficult than others. So this part represents all the sediments coming together and being compressed. So instead of years and years of gravity and water and pressure, it's just letting them sit for a day in this mold.
Now that I'm back from my date, I can tell you what the purpose and my hypothesis is for this sandcastle experiment. So the purpose of this experiment was to see which combination of sediments would make and create the strongest sandcastle. My hypothesis is that the water and the sand would be the strongest.
My hypothesis is that the combination of sand and yogurt will actually create the strongest sandcastle.
My hypothesis is that the sand and the glue combination will make the strongest.
Oh, yo, it's DJ Yellow Joe in the house.
Oh, this is my breaded show, okay?
Yo, I think that just the sand would be the best sandcastle. Yo, DJ Yellow Joe knows, okay?
Get lost.
Okay.
Get lost. Hello, ladies and germs. I'm back 1 week later with my assistants.
Hello!
Hi.
We have let our sandcastle sit for a week.
Oh, hey, for a week we let them sit. Now let's see which one is a real hit. Hey, DJ Yellow Joe.
Wow, thanks for that, DJ Geologist.
Thanks so much.
Yeah, so as she said, we did let our sandcastles sit for a week to represent the compaction that the sediments undergo in the rock cycle. Although in the real rock cycle it takes millions of years, ours only took a week. So now we're going to uncover them and see which hypothesis was successful and which one.
Hey, whoa. We all know the sand is going to be the one. Okay.
Yes, you want to uncover and see?
Oh, yeah, baby. Okay, yeah. Move.
Okay,
All
so
right.
the first one is the sand, which DJ Geologist thinks is going to be the strongest.
Okay, shush. Okay.
Okay.
What a fail.
What is this? You're hacking.
As you can see, the sand had nothing mixed in with it to keep it together. So when we took out the mold, it completely fell.
Okay, you know what? Okay, so it's all rigged, okay, guys? Like, come on.
The next one is going to be the cement with the sand, which I believe would be the strongest. Ready, ladies? So I'm going to put the pressure. I'm going to lift. Oh no, ladies. But it's somewhat still. I mean, it's still pretty strong.
Yo, I'll do the soap. This is gonna be so clean, yo. Oh.
Okay.
Okay.
Oh, okay.
In this mold, we have the salt and the sand. So let's apply the pressure. Oh, I don't think so. Oh.
Pretty good.
It seems as if the salt and the sand has stuck
On the mold.
to the mold. So this one is the one that we mixed with yogurt. It was cherry, just in case you were wondering. I think this one is going to be the strongest. I think I'm wrong.
Okay.
That's pretty good.
Okay, a little better than I thought.
So in this mold, we have the oil and the sand. So let's apply pressure. Oh,
Whoa! Okay, yo, the next one is glue. Just like family, we stick together. Let's see if this sticks together. Okay. Pressure. Oh. Whoa, that came out nice.
Okay, now remember, ladies, when you were younger, you was on the beach and you used to make sandcastle just with the water. Same idea here, water and sand. Let's see what's good, ladies. Oh my God, your sandcastle, lady, let's go.
The next one is the one that we mix with some soil, water, and sand.
Wow, ladies. Oh, not bad.
So this one actually stood together. Okay.
It's a cupcake.
Adequately. All right, yo, so we're going to apply some pressure with a plate. And we're going to see which one of these is the strongest. All right, Lara. Cue.
okay. So we're gonna put on this one first.
Which was the cement and sand. Okay, so this one actually seemed to solidify pretty well, and you need to apply a significant amount of pressure.
As you can see, after weathering, erosion, and deposition, it turns back into sediments, ladies.
This is the soap, guys.
Ooh. So that one,
It's a pancake, yo.
the soap and the sand actually seemed to stick together pretty well, but it just didn't harden enough. So this is the salt and sand one, and it didn't really seem to come together that well, so we're just gonna move this off to the side. The yogurt and sand
It's
one.
rotten, ladies.
Let's
1 week
see.
later. Oh, say bye-bye.
Lara,
It's
no.
You're doing the other one too, lady.
Yeah, so that one, same thing as the soap. It stayed together pretty well, but
I think,
Yeah.
guys.
sorry. Okay, so this one was the oil one. We'll do when we apply pressure. Okay.
You also take that slide to the left.
And this one was the glue one. So we'll see if this still sticks together.
Oh, say tata bye-bye too. Now, the also glorious water one.
This is the one with just water
This is
and
not
sand. Okay, a little more resistance than the
Yeah.
other ones. Didn't go down as smoothly. And the last one is
The soil.
Yeah, so that one just like completely collapsed.
Now, which one was the strongest?
So, ladies, as you can see, the cement held the strongest,
Oh,
but the water and the sand tend to hold its shape better.
All right. So my hypothesis was just the sand, and I don't know if it's rigged. I don't know, but like it didn't hold up really well. I think my hypothesis was pretty bad. It's fine. It's fine. I got the rap game. I don't need science. Who needs science? What? Okay.
Bro, that sand felt like a career. So, as Raj Patel, the geologist, thought, I guess the cement and the sand was the strongest. It definitely did not hold its shape the best, but it tend to be stronger than others. As you can see, a bit of the rock is forming.
That one actually hardened the most. So after time, it seemed to have stuck together better than the other one.
And if it was to be millions and millions and billions of years, bro, this stuff would have been rock.
Yes.
Trust me, okay?
Yo, trust chic scientists.
So initially, I thought it was gonna be the glue. However, as you can see, it didn't hold up together. It just flattened.
So what I thought was going to hold was the yogurt and sand, but when pressure was applied, it kind of just fell. So as you can see, a lot of the combinations that we did produced the same sort of reaction when we applied pressure. They kind of all flattened out, except for the cement, which sort of crumbled because it actually stuck together.
Okay, now ladies and germs, now I'm going to be telling you how our experiment relates to the rock cycle. Now, come lady. Please come closer, camera lady. Our experiment relates to the compaction and pressure on the sediments forming sedimentary rock. We experimented with different combinations of sediments that include sand, soil, cement, and etc. The different types of sediments found in nature include pieces of rock, fossil, and dirt. Thank you, ladies and germs, for watching another episode of Raj Patel, the Geologist.